Well, welcome everyone back to the general session. One reminder here is to submit lightning talks for Wednesday. The voting, I believe, begins at 6 p.m. and the notifications will be by 6:30 p.m. So you definitely want to, get those in now. The other thing is, I think we're going to have something about the vendor collaboration room in a little bit, and I think there's a reminder here for the social tonight at the Clift Hotel at 8 p.m., and which will be hosted by Coresight and Hurricane Electric. And we're just going to begin with the lightning talks here. Up first will be Carlos Vicente with the University of Oregon.
Hello. So I'll be talking about this open source tool that we've been developing and using for a while, and the hope is that it's useful for other people. So what does it do? It basically, there are several things. It discovers devices and their topology using SNMP. It's also a IPAM software, so it organizes your IP address space, IPv4 and IPv6. It also can be used to document your cable plan, so all your fiber and copper assets. We use it to organize all the contact information that we deal with, and it also generates configurations for other tools and has role-based access control. So why did we start this project? We really wanted to centralize and integrate network information. This has the characteristic that it reduces manual processes. As everybody knows, manually added information becomes outdated really quickly, so the idea was to reduce that as much as possible. Also, we wanted to generate reports more easily, and if things were scattered everywhere in several text files and different databases, it was really hard, but this facilitates the reporting. We also wanted to delegate tasks to departments so they could deal with their own information. And there were no similar open source projects. Other tools were doing one thing very well, so they did device management very well, or they did IPAM very well, or fiber assets, but no tools that I knew of were doing it all together. So in our operation, NetDot has become the source of truth. So we go to NetDot to find out how things should be. And we use it, as I said, to generate configurations for different things. So we generate our DNS zone files, our DHCP configurations. We keep our Nagios updated, Sysmon also, and we populate the cacti database from this, which is really useful. And of course, rancid. Every time we add a router or a switch, it gets into rancid automatically. So about the device documentation part, a lot of information, interfaces and IP addresses, subnets, VLANs, modules. We collect ARP tables and forwarding tables and spanning tree information. Of course, manufacturer model, version of the OS or firmware. And if you're familiar with NetDisco, another very good project, we borrowed their SNMP info libraries. And they do a great job of finding the right OID in the MIPS for each individual vendor. So also, the layer 2 topology discovery, kind of unique in its own way. We collect and analyze different sources of information, CDP and NLDP, spanning tree state, and forwarding table data. We take all those sources and we come up with a good guess of how things are connected, and it works really well. Of course, we can add more information to each device manually, so where it's located, who the contacts are, how we want it monitored, how the ports are assigned to jacks, etc. This is an example of a report where we see the devices and we show the manufacturer model, OS version, and how many devices of each model we have with a certain version. So it's easy to know what we need to update. Topology graphing, also very useful. Yeah, you can take one node and say, I want to see all the neighbors of this node, and how many hops away you want to graph. So you can say 1 level, 2 levels, 3 levels, or infinite, which graphs the whole network. Another very useful part of it is you can visualize your spanning tree state. So you can make sure that the root is the one that's supposed to be, that the priorities are set correctly, etc. What interfaces are participating in the tree. Then moving on to the IP address management part, it organizes, as I said, V4 and V6 address space hierarchically, and it uses a trie algorithm. So each time you add something, it updates the hierarchy pretty quickly. And since we have device management, we take advantage of device discovery to insert new subnets when we discover layer 3 devices. It also shows graphical representation of IP blocks. It generates DNS zone files and DHCP configurations right now for ISC bind and DHCPD. We use it to track IP and MAC addresses over time. Another very useful thing is it generates A and quad A records for router interfaces. So we don't have to maintain that manually. You bring up a new interface, discover the router, and it generates the A records for that interface. And of course, we can delegate the management of address space to departments that want to deal with their own records. So it takes a lot of work off of our daily routine. This is an example of our IPv4 block view. This is a /16, and it shows all the subdivisions, all the allocations. You can see in the green space is space that we can allocate. The yellow space is it means that there's subdivisions within that, so that's a container, and we use it almost daily to find address space that we need to allocate. Really useful. Looking at a subnet, if you click on one of those allocated blocks, and it happens to be a subnet, you see all the addresses in that subnet and how they're distributed, how much has been allocated for dynamic DHCP, how much has been allocated statically. You can see some purple cells there. That means that those addresses have been discovered in the ARP caches of the routers. So you might want to notify the users that they're pretty much stealing an address. And on the IPv6 part, we can generate graphs of the hierarchy in a tree view. We're working on the other kinds. I'll talk about that. Cable plans, so we document inter-building fiber, copper bundles, and also in-building fiber, so we keep track of rooms, jacks, closets, and we can also use sequences of pairs of fiber to create circuits. And then those circuits can be associated with device interfaces. So it's all correlated. This is an example of the backbone cable plant graph. As you see, it shows all the fiber between buildings, and in those little numbers, it means that those mean that those show that the individual strands that are available or used. So you have an idea of how the usage of the backbone. We keep closet pictures, and we're working on some features. First one is RESTful API, so it makes it much easier to interact with the application from external programs. We're working on IPv6 address space visualization, and right now we're kind of playing with the idea of a hierarchical quad tree model. We'll see if that proves useful, but I'm kind of excited about that. I also need to add IPv6 address collection via SNMP. Right now the libraries don't support it, but it should be easy. Also DHCPv6 configuration support. We would also like to be able to update DNS using NSUpdate instead of just generating zone files. And particularly because that would help with taking advantage of bind's auto-signing or auto-resigning feature. More features, we're improving the cable plan section, adding more details about different types of splices and termination. We also want to keep track of equipment stock, so things that are that haven't been deployed yet, and we could take advantage of barcode scanners. And also more access control granularity, so that we can give people specific access to things. Right now it's kind of all or nothing. So I would encourage you to try it out and join the mailing list. Let us know how useful it is, if you have suggestions, etc. Do you have time for questions? Any questions?
Questions for Carlos?
Yeah, one question. Two.
Go ahead, Tom.
Yeah, just saying this is really timely given some of the content on the NANOG list. Thank you.
Thank you.
Yeah, Joel Yeagley, Nokia. Wow, it's come a long way since I left the U of O. Awesome. Thank you.
Thank you, Joel. Thank you very much for listening.
Midori? Yeah, okay. Next up, we have Doug Midori with Renesys on accidentally importing censorship.
Everybody, this is a slightly revised version of a talk from yesterday's BOF of Death, entitled Accidentally Importing Censorship. My name is Doug Midori. I'm a new face at Renesys, and what this is about is a behavior that we had observed in March, where users outside of China were experiencing DNS tampering, very similar to what's been documented with Chinese internet censorship, due to a route leak for the iRoot instance in Beijing. So a couple points about Chinese internet censorship, also known as the Great Firewall. It's known to block IPs and prefixes to return incorrect DNS responses and reset TCP connections. DNS queries specifically through the Great Firewall can return bogus queries. And in March, we observed this affect users outside of China. Now, one note of clarification that I think we had some confusion yesterday was we can observe the data and we can try to draw conclusions. We'll never have anything approaching an absolute lock-on attribution of who is doing. So if it's somebody's homework assignment or a state or government. We don't know, but we can report on the behavior that we observe. So you can impress your friends at parties. You can try this for yourself and see what it looks like. You can try to hit a DNS server for a blocked domain in China and see the kind of results that you get. Chances are you're probably not even getting an answer from the DNS server based off of those people who have studied how this is actually implemented on Chinese networks. So the other piece of the story here is the iRoot. So the iRoot's seen globally via /23 and /24, originated out of a dedicated AS transiting 8674, and it's operated by NetNod. And there are 34 instances of the iRoot across the internet, including one in Beijing, the one that we'll be referring to in this talk. It's important to note also that F&J also have got instances in Beijing. So the story begins in late March, where an individual from Chile wrote an email out to the DNS operations list about a local ISP observing some strange behavior on DNS queries, DNS responses. Specifically for Facebook, YouTube, and Twitter, instead of getting the expected referral to the .com server, they're getting these random bogus IP addresses. And for people who have studied DNS tampering in China, this is exactly what this kind of thing looks like. So when we looked into this, we found that there was a leaked path, a leaked route for the iRoot out of Beijing, where it was transiting 24151 Chinese AS, and then eventually making it back out of China to, in this case, 10,026 PACnet, and then on to their customers and peers and the networks that they serve. And so by crossing Chinese networks, these DNS queries were actually getting subject to this tampering behavior that has been studied. But to actually have this happen to you, a lot of bad things, you need to be very unlucky. So there's a lot of conditions to be met. You need to query a blocked domain. You need to have it not cached by you or your DNS server. You need to have .com also not cached, and it's got a 48-hour TTL. When you go to query a root server, you need to get the right one. You need to go to iRoot, and you need to be in that footprint of the route leak to get China's, the Beijing iRoot instance. Had you met all of those criteria, then your query to a blocked domain would not return a .com or whatever server. You would get a bogus response back, and in what was observed in March, those responses had a 24-hour TTL, so for 24 hours you'd have a poisoned cache. So what this plot here illustrates is the two prefixes that iRoot's seen globally, the /23 and the /24. We never saw this behavior for the /23, but we did see this for the /24, where beginning in January and creeping up into late March, we saw more and more of our peers seeing this route in Asia, and until that email had come out, it also went out onto the NANOG list, and the following day that route was withdrawn, and really had been gone for a couple of months, and we were actually preparing a talk for this NANOG last week and just recompiling the data to make sure we had it all right, and we noticed this thing had come back last week, which is hence the timeliness of this talk. So as of today now, this leak does continue, and answers seem legitimate now for those users that are seeing the route. Is there a question?
Yeah.
Yeah.
I'm Dave Meyer, but this is a question from Curtis Lindquist.
Okay.
He's asking, are you actually seeing incorrect responses outside of China?
No. And actually, I've got that in the presentation. But that's a great clarification. I think, that's later in the presentation. So this is what this type of behavior looks like. This is an example of DNS tampering just recently. This is a client in China where trying to query a blocked domain. The domain, we use Facebook throughout this presentation as an example. You could use any of these. There's tens of thousands of blocked domains. Things that aren't blocked are getting through, so don't get too caught up on the use of Facebook. It's not just Facebook. But here's an example where you're getting a random IP address as a response. And this is kind of the play-by-play out of TCP dump of what this transaction looks like. So in the first block, you see a query going to the iRoot. The second one is the bad answer coming back, 4 milliseconds back with a bad answer. Another another bad response comes back just for good measure in case you didn't get the first bad one. And then the client tries to take the first one, tries to work with it, gets the second one, doesn't expect it, so sends back an unreachable. And so this is expected behavior. This is something that's been well documented on Chinese networks. And this client, this is a client inside of China. and actually you see the same behavior for any root server or just about any DNS query. So this isn't specific to a root server. Is there a question?
More a comment.
Okay.
That's the multiple answers is usually a fingerprint of packet injection where you have multiple injectors running. Often if you see the IP ID and other things, IP ID and random IP flags may often be able to fingerprint the injectors themselves.
Okay. So now we tried to take a U.S. client with PCCW Transit that was seeing the route in question and see if it would get good results. So just to confirm that we were crossing the path that we thought we were crossing, we performed a trace route, did get an IP address from 24151, which is one of the Chinese ASs, and did get a good result. So that's a different behavior than what was observed in March. But then the Chinese client that we looked at earlier also started to get a good result when querying a bad domain, block domain, and but then 45 minutes later getting a bad result again. So there was some non-determinism as far as when this occurred for a client in China. So to answer Kurt's question from earlier, and we have non-Chinese clients of Beijing iRoute, to the best of our knowledge, are continuing to see correct answers. We have no recent evidence of bogus iRoute responses outside of China, and from what we can tell, NetNod and Kurt's company, they're serving up the data cleanly and routing properly. But the DNS injections observed in March are kind of typical of what we would see for a client that was inside of China. And this isn't a point source problem. This is a widespread problem of clients inside of Chinese networks. The F and J routes also have Beijing instances, although we haven't really observed this type of leaking coming out of China for them. And as long as this route stands, there is some risk here that the behavior that we observed in March could possibly return. So this was Kurt and a couple of our engineers at Renesys did exchange a couple of emails about this. Kurt did post his response to the DNS operations, and I believe as well as the NANOG list, stating that he didn't have any insight as far as the mistake that occurred in March, but had been assured that it wouldn't happen again. And some questions remain in our mind as far as what was that mistake that happened, and what was the remediation, and then also what's going to happen going forward for this type of for this route. So quickly, our recommendations here are we think the root server operators ought to keep a close eye on the routes people are using to reach their instances, especially we'll call them in the challenging networking environments. And it's great to operate a domestic local instance of a global service. If that's your intent, it's probably best practice to keep that as a local domestic service. And we, as a community, ought to take some responsibility when we identify a leak like this, to do what we can to try to plug that leak. Thanks. Are there any other questions? Yes.
Randy Bush, IIJ, channeling Curtis.
Okay.
I can get bogus DNS replies here for sites too, here being Stockholm at the moment.
Okay.
All done by my friendly ISPs in the name of child protection. Has occasionally protected children from Pirate Bay, holiday photos, and God knows what. Make that God and the police, as they refuse to say anything about what makes it onto the list. The same is true for Norway, Sweden, Finland, Germany, Netherlands, UK, Australia, and probably a bunch of other Western countries. Then I can add all of the Middle East, and we won't have many locations left for root servers, will we?
It's a valid point. It's a valid discussion to have. I think there's been some discussion about, if you did put hotels and other companies do filtering and DNS blocking, and the question is, do you want to put a root server there? So, thanks. Oh, sorry. One more question. Okay.
Jay Hennigan. So this doesn't parse for me. I have no insight as to why or how it happened, but it won't be possible for it to happen again. If you don't know why or how it happened, how can you be assured that it's not going to happen again?
Well, I will have to defer to Kurt on that one. Thanks.
All right, next up, we have Robert Razuk with Cisco and some BGP-wide communities.
F5. Did F5, but okay. Hi. So this talk is actually about using BGP communities. This is the most common tool which most of you are extremely familiar with. The URL here, in fact, includes all the latest material. The reason for the talk is I met 2 weeks ago a customer, live customer, who got assigned the 4-octet AS number. And with today BGP encoding, he is not able to inject any BGP communities, in most implementations at least of BGP. So clearly there is a practical need to be solved. So first I'll talk about the current BGP communities, then I go into the proposing new encoding, and if we're proposing new encoding, we have a unique chance to actually get together and define a whole bunch of new well-known communities. Well-known is kind of oxymoron here, but well-known predefined communities to be used in operational life. Because currently, each of the providers maintains a web page of its own communities, and if you want to have any action done, you have to negotiate by telephone, by email. That can change. So currently, the RFC for BGP communities, it's very simple. It has been done about 13 years ago, and it defines 2-octet for AS number and 2-octet for the value. And the AS number, it is said specifically in the RFC, indicates the source of the community. That's also something which I would like to address. So there is no way to encode 4-octet AS number in this encoding, and the well-known ranges don't even allow to encode any AS number. So essentially what I'm proposing is to use the regular type of external community, basically define the new type value, both for transitive and non-transitive cases, and have 7 octets left to play with, because external communities are 8 octets in total. Additional octet I use for actions, and I'll show you on the slide what the actions actually mean. What is also most important, in this new encoding, I would like to use single encoding for both 2-octet and 4-octet AS numbers. So we limit the number of problems to the minimum. Another thing, it can include AS number as the parameter of the community. So today I have no way of actually indicating in the community that this action has to be done only if given AS matches. And I'll give you to some simple examples. What do I mean by that? So actions, in fact, the additional octet allows me to define a couple of new behaviors, in fact, 256 or 255. I'd only define 2 here. One is informational support. So if I'm an AS which supports given set of communities, and those communities can be injected by someone remote, I can indicate that I'm supporting that. No action on the router is necessary. And another action is mandatory, means that if I'm supporting given community, I better execute it or drop the update. To some extent, this behavior may be useful in some networks. It is not to say that I'm making communities mandatory. No, communities are still on a best effort basis. Some vendors can support some communities, some may not. And this doesn't change. So the new encoding actually allows you to specify 42,000 of your own communities, and I'm reserving about 20,000 for predefined ones to maintain in database. So this is actually an opportunity to give huge credit to all of you, because I'm not a genius. I didn't invent all of those. If you want to talk to the genius, you go to the Apple Store. This is some list which I basically just grabbed from the web pages of what the most common uses for BGP communities are today. And I combined it together, compiled into the list of kind of predefined values. And this is exactly excellent moment for you all to give me a feedback because I hold on publishing the draft before I get more feedback. I already get some good feedback from a lot of operators, but I need more. I mean, the more we have, the better the outcome can be. So far I defined the black hole with the source AS. So basically I defined that I want the black hole only if the source AS matches. Source black hole, basically on the direction from the customer to the network. Source RPF, and higher priority prefix. Another set of communities control the advertisement. For example, I want to specify as a parameter in the community to which AS I don't want to advertise given prefix. Or I want to specify to which AS I want to advertise given prefix. So those are options which are all not possible today by using normal communities because those are not AS-specific communities. Most of this is, I think, straightforward. You see from your operational life that you often mark routes as coming from peers, from customers, internal, and then based on this coloring, you execute some policy on eBGP peers. Another interesting hint I got was actually the path hint from Brett Sweeney work. It allows you to actually tell remote AS that your preferences on the return traffic to go through some path which contains given AS number. And that's perfect use for, again, parameter AS in the community value. And the same for negative hint. That's I invented, just to complete the picture of what ASs I don't want to use for transit. Because if I'm remote AS, I do the path selection. I can easily choose what do I select as my best exit path. Today, I use normal steps. With this enhancement, I can get more control. Another set is to define the, to change the path modifications of the BGP. So I can replace some ASs. This is perhaps not too good to the internet community, but we do have cases of customers needed it for other applications. Prepending, in fact, it's very, very common. And for prepending, we're actually trying to make an effort so you don't need to break update groups. You can do the post-update group prepend without any policy specific to outbound route maps or outbound RPLs. And the rest of prepend upstreams, peers, customers remains as is. Another group is basically marking geographically. I mean, this is all in the draft, so you don't need to basically keep in remember those. Another one is to increment or decrement local preference. I actually had to struggle a little bit on that one to make it useful. And I just want to increase or decrease from a given value depending on the community I see on the incoming updates. And the last one is the Tony Slee proposal, which was kind of separate draft for IDR. And this is actually something which can be easily defined here in the community space and used as the radius for update propagation. Basically, dropped if AS path equals 1, 2, 3, up to 15. I think it's more than enough. So that's pretty much it. It's a short lightning talk. If you have, as I mentioned, any feedback, please let me know. And if you have any questions, please go ahead and ask now. I think we have time some.
Yeah, I know we're a little bit
over
behind,
time, but
it's fine.
It was after lunch.
FTP-ench@cisco.com. I haven't seen that in a long time.
I'm sorry?
No, FTP-ench@cisco.com. There's a lot of interesting stuff on there.
Hi. Richard Steenberg and NLayer. One of the problems that I have with predefining all of these type of actions is where they're applicable is very specific to policy. So for example, you may not want your peers being able to say no export to this ASN or that ASN. You may want your customers, you may not even want your customers to be able to say no export in this region because that may violate your peering requirements to announce consistently. There's so many things that are just so specific, even location coding, adjusting local pref. You're talking about adjusting local pref by 20, 30, 40, 50. Some people have local prefs of 1,000, 2,000 a million. There's so many things out there that are just impossible to standardize like that. I want to see more support for being able to use the extended communities to be able to do things like specify actions to use that extra type information to say apply this action to this ASN versus use this only as informational. But it kind of gets weird when you start talking about predefining all these action types.
Well, so the only comment I would say, I just collected the most commonly used ones. Of course, as you are correct, that each AS, it's very topology specific, may have a whole bunch of new defined definitions to be done. And this is still there. So as I said, 42,000 are left for you to play with on your own.
Well, it's one thing if you're showing examples. It's another thing if you're predefining these and expecting these to ever be implemented. Kind of like the no peer community. How many people here support that in their configurations today? Probably nobody, because no one goes out to configure that. It's not used.
Well, so actually the feedback, if it's negative feedback, if I should remove something, it's also good. But if somebody makes use of that, I would rather leave it, and it's optional anyway.
Supplying it as examples is probably good.
Okay.
But I'm not sure about leaving it there as it's supposed to work for everyone by default, because you have to write the policies for it, or it's not going to make any sense at all.
Right. So actually the draft specified some more descriptions. This is just the list. But you are right. I mean, it would be very nice to have good uses for each defined along with the draft, yeah.
So Joel Yeagley, I guess OPSEC Working Group Chair. This subject actually came up in the context of RFC 5365, which was the remote triggered black hole filtering, whether or not communities should be standardized in order to support that. Since one of the authors is at the mic in front of me, I will defer to him on the opinion on that, but I think the general opinion of the working group was that it's somewhat dangerous to standardize communities that there's not a broad spectrum of agreement on, and there are relatively few where there are, for mostly the same reasons that Richard Steenbergen has described. That said, this is a room full of people who could actually do that. So, like, I wouldn't necessarily dissuade you from heading down this route so much as I would say that there's sort of like, if there were a community consensus that standardizing certain communities was a good idea, that would be something that could be documented.
And that's precisely what I'm looking for. Basically, some broader consensus of what makes sense to predefine, what not. Keeping in mind that it's not obligatory to actually execute them. It's still to be enabled by hand on a given router to execute given set of communities. Danny?
So yeah, Danny McPherson, yeah. So part of what Joel said, and I think I agree with Richard as well, in that these are certainly topologically dependent, or I think as a matter of routing policy, certainly every routing policy I worked on, we didn't transit any communities. You reset those on ingress, and not only because of different people's interpretation of those, but also for things like the more unique attributes you have, the bigger impact you have on inability to do update packing or scalability of some of the systemic state and routing systems. So that's part of the concern Joel was mentioning, the OPSEC working group, which I think you knew already. So anyway, just wanted to reemphasize that.
Yes, so for resetting on inbound, indeed, but with current packing being 3.2 or 3.5, I don't think it's a big difference. But I think in general, the feedback which I'm looking for particularly is a good idea to remotely execute some actions. That's something which is not happening today, and to some extent I think it could be useful, and I heard actually during presentation yesterday and today some examples of these requirements in the presentations.
Right. I think the only thing I would say to that is it's a bad idea to assume that a community is going to be transitive in the real internet, right? It's a really bad idea to rely upon that, because a lot of people don't transit those; they reset them. But anyway, okay.
Thank you.
Leo Bicknell, ISC. Comment that actually kind of goes with both the last presentation and with this presentation, so I can comment on two at once. I work for the company that runs FRoot, and I think, not that I've ever talked to them about how they do it, iRoot's kind of routed similarly to us. We use the no export community today. We're probably one of very few people like them who try to use this with tons of providers all over the place. And my little rant with this that I've given to many people is, if you read the BGP RFCs, it says if your implementation supports communities, it must know about no export and no advertise. And the software does. You know, Cisco, Juniper, whoever got this right in their software. The ISPs then go and write a route map that says delete all communities. And so the must be supported feature doesn't work. You send them no export and they happily drop it on the floor because they never wanted to hear a community from you. And if you go way back in history, there was almost a good reason for this. There was a time in your router software where deleting everything but no export and no advertise was somewhere between painful and impossible. But I don't know, 5, 10, 15 years ago, it's been a while now, all of said vendors fixed this. You can define a list of allow no export, allow no advertise, delete everything else, and say on my inbound, do that. One of the reasons, I think, probably iRoot, and I know FRoot from time to time has had leaks, is we send no export and people ignore it. And so I have a kind of a couple of part plea there. One is if you're an operator, your software now does this. Please think really hard. I understand you probably don't want to take 50 million communities from your peers and net exchange points and all this other stuff. Could we just get no export and no advertise to actually work internet-wide? Because it would really help a lot of people. But that, I think, goes to the fear with this. As a network operator, I find this frightening because my users are going to expect the well-known communities to work. As a user, I think this is great because I wish all the providers would implement a good part of that list. And if it was a way to kind of force that, it's good. So I'm a very mixed mind on this and whether it's a good idea. A lot of Richard's concerns from the operator side about defining these because people are going to send them and expect the behavior to happen. And when it doesn't, then you run into things like I'm running into now with no export.
Yes, excellent feedback. All I want to add to this is that perhaps I choose a very bad name. Well-known means too much. What I really wanted to define is community templates, essentially, which just define the format of a given action. And there is completely, as you say, no way to guarantee that something is going to be applied or not on the remote AS or even on your transit partner.
One quick question, I guess, for Leo I had that was mentioned was, you said sending no exports. Do you mean transit providers or peers? Do you expect your settlement-free peers to accept you to traffic engineer them by no advertising, no export?
My expectation, given the way we work, and also my interpretation of how I think the software should work, so that's very caveated, is I think I should be able to send no export on any session anywhere, and the other side must honor it. And I take that because the RFC says if your software supports communities, you must support no export. Now I realize that it doesn't say, and then you also have to write your policy to do that. You know, there's a whole different thing. There's a difference between defining how code works and defining how somebody configures their routers, and we can debate that all afternoon. But it really seems to me in those cases it should be a must. And I mean, I could debate on everything in his list, whether they should be musts or nice to haves or maybe somebody will do it or whatever. You know, to Richard's point, a lot of the things that are proposed can potentially have downstream consequences. You know, if I don't advertise to like 3 peers, maybe that violates some other agreement or other things. I think generally when you talk about a few core things like no export, there's almost no pitfall there. I'm sure somebody somewhere will probably find me after this and tell me what the pitfall is, but it really is, you know, kind of pitfall free. So yeah, I think it should be a must.
We just have after Joel. Probably
right. Really quick observation. If one were to produce a BCP that contained a template for a set of well-known communities, the question you would ask your ISP is not what communities do you support. It is, do you support BCP foo community templates?
Yes, and that's precisely the point of that list, in fact. I knew I'm opening the Pandora box here, but thank you for all the questions. Thank you.
Thanks for the lightning talk.